Hey everyone, I'm Michael Hall, and you're watching Innovation Coffee brought to you by ARM, where we give you a deep dive into the ARM developer ecosystem with special guests and topics that bring you the latest innovations that are happening on ARM. This episode is going to be all about PyTorch Con, which just happened, and we had a great presence there. We're going to start with Gian Marco Iodice, who gave a talk at PyTorch Conf and is going to give us a quick overview of what that talk was about, some teasers about it. Then we're going to go and look at the demos that we had at the ARM booth there and get an update from Gabriel Peterson, one of our developer evangelists who was at the event. Lastly, we'll wrap it up as always with the learning path updates from Pareena Verma. We're joined now by Gian Marco Iodice, one of our engineers who's been involved in AI and ML at ARM for quite some time now. He was recently at the PyTorch conference where he gave a presentation on enabling accelerated AI everywhere on ARM. And he's come to our show today to give us a little bit of a taste of what that presentation was like. So, Gian Marco, welcome to Innovation Coffee. How are you?
Very good, thank you. Thanks a lot for inviting me. And it's actually a pleasure to talk about this talk that I delivered at PyTorch conference, which in short unpack the meaning of the title I choose for this presentation, enabling AI everywhere on ARM. And certainly the one of the most important word of this title is everywhere. Why everywhere? Everywhere because ARM is everywhere actually. We have, apart from shipping a lot of devices ARM powered around the globe, everywhere means that we are in 99% of the global smartphones, but also in 100% of the leading cloud service providers. But what it means that this technology is truly pervasive, is everywhere. And since this technology is pervasive, we have an important role. Help our developers to leverage the AI capabilities everywhere in a very easy way in order to achieve the best performance. And we understand the role of software because software and hardware are certainly complementary. We need both to achieve the best, right? In particular in this field where everything is changing so rapidly. We don't want to put barriers in front of developers. And that is the reason we have developed, for instance, KleidiAI, one of our latest library for accelerating the performance of AI workloads on our CPU. When we say about software means a lot for us. It's in our DNA for quite a long time. I can also share some data because 40% of our people are dedicated to software projects, and these investments have been done for at least 15 years, and not just to. In just a few projects. I would say that as we can see here, we have thousands of projects, and most of them also are open source contribution. Open source contribution also with our partners. So as I said, software means a lot. Another important point that I have presented at PyTorch conference is about the use cases with Gen AI in particular. Gen AI that we hear a lot nowadays. What I said at PyTorch conference, I don't want to look at the future. I want to look at the present. What can we do right now, for instance, both in the cloud and at the edge or on mobile phones? So this is an example of what we have done recently, for instance, in the cloud with the Llama 3.1 with PyTorch. In PyTorch, we have integrated our software optimizations through KleidiAI. And here we have a demonstration of a chatbot that interacts with us. But in addition to this demo, what we have done also several demos in the mobile space. And here we have done in the last 6 months also incredible things that honestly I could not imagine for sure 2 years ago. And I'm saying this because in particular, we have also wrote a blog post recently. We have managed to have an on-device voice assistant that does not require internet connection, and it can run only on a mobile CPU. It was an interesting project also for me because, as I said, I could not imagine something like that 2 years ago. And we managed to run this demo on a 2 years older phone, which is absolutely amazing. This is actually a demonstration that Gen AI is not something that will happen. This is something that can be done already on ARM, in particular on the ARM CPU. The other point that I mentioned at the PyTorch conference was about the important role of having an efficient processor. Efficient not just from a computational perspective, but also from a power perspective. And this slide actually summarizes the crucial challenge that we have in front of us. So if you factor all these elements together, you can realize that basically we need a lot of power, a lot of nuclear plants, for instance, or in order to have enough power to leverage these applications. And the role of ARM is actually to provide a processor that can leverage the computation in a very efficient way. But this is not something new for us because it is in our DNA. Our investment started well at the very beginning of the first machine learning workloads on mobile platforms. I have seen this already 10 years ago when I joined the company, and we're trying to leverage the first deep learning models on mobile. But this continuous investment actually made not just the processor more efficient from a computational perspective, but also much more power efficient as well. In the end, what I talk about, I talk about the important role of software. Software is crucial because it gives it gives to developers the opportunity to be creative. And when we are creative, certainly we can create a novel solution that can be incredible in the hands of many people. When I talk about software, I also want to be practical and explain why software is important, in particular in the context of Gen AI. In this slide, I reported a few large language model sizes, okay, that we can find, for instance, designed by and created by developers worldwide. All these models certainly can run well in the cloud, but there is also a portion of these models that can run also well on mobile and at the edge. And if this is possible to run these models on mobile and at the edge, is because of what we have seen also 10 years ago when we were leveraging the first deep learning models, quantization. At the time, we were talking about integer 8 quantization. Nowadays, we are considering more extreme compression techniques, like the integer 4 format. But when we talk about integer 4 format, there isn't a single quantization format that fits them all. And what it means that there are different ways to perform this extreme compression technique. And here in this slide, I have reported two probably of the main techniques that we have seen so far. The one called per channel quantization, when you use only one scale factor for representing the entire quantized array, or the per block quantization, when you have a fixed block and you have a floating point for each of these block, and each block basically represents the quantized data. Well, as you can imagine, since they have different schemas, what is crucial here is to have the software flexibility to represent this. And actually, this is the benefit offered by the ARM CPU, because it offers the programmability that you need in order to keep pace with the innovation that we are seeing in this field, in particular in the context of compression techniques for large language models. And that's it. So these the main points of the presentation. In the end, I talk about our latest products, which are the KleidiAI and KleidiCV. So the KleidiAI, which is our latest product library that we have designed for accelerating AI workloads on ARM CPU, is designed to offer the optimization for the critical routines for AI workloads. KleidiCV is basically the library for computer vision frameworks that offers the critical routines for computer vision workloads. And that's it.
All right. You can find the entire presentation that Gian Marco gave at PyTorch Con at the link below to find out more about that. Gian Marco, thank you so much for being on our show.
Thanks a lot for inviting me. Thanks a lot again.
All right, now let's go to the demos that were at the ARM booth there at the event. We had 2 great demos showing off the strength of generative AI on ARM CPUs.
Okay, so hi everyone, I'm Gian Marco from ARM. I'm the Gen AI software engineering lead, and today I'm in the PyTorch Conference 2024 at the ARM booth, where we have the demo where we demonstrate a chatbot running with a large language model on device on an ARM CPU without internet connection. So in particular, in this video, we have the demonstration of what is feasible today on mobile, just running on mobile CPU with ExecuTorch and KleidiAI. If you're not familiar with KleidiAI, KleidiAI is our latest software library for accelerating AI workloads on ARM CPUs.
Hello, this is Nobel Chaudhary from ARM. I work as solutions engineer in infrastructure engineering team. So today we are gonna see LLM inference with PyTorch on ARM demo. So let us walk through the PPT to just understand what this demo is and just jump onto the real-time demo that I'm running it here today. So LLM inference with PyTorch on ARM. So here we are doing like on CPU inference, and this demo runs the Meta Llama 3.1 8 billion parameter model with PyTorch on ARM Neoverse-based V2 CPU, which is available as Graviton 4 on Amazon Cloud. So this is the architecture of the demo here. So here the user is able to enter the input through the Streamlit front end, which is running on the AWS Graviton 4. We are running the Meta Llama 3.1 on ARM-based CPU as LLM backend, which will be doing the token streaming to the front end. Here we are using the PyTorch and ARM KleidiAI library, along with the OpenAI framework, which is used to make the communication between the front end and the back end for token streaming. So here we are getting the LLM response and also logging the metrics that shows you the tokens per second and cost, what is like per dollar. Yeah, this is about the KleidiAI. KleidiAI is like an ARM AI library, which brings in the performance gains for Gen AI inference on CPU. It is an open technology, and it empowers developers, and it brings up the ecosystem strength. So you see, like for whatever the ARM hardware, the past one, the present one, and the future one, Kleidi is like a software framework which brings in the performance gains for Gen AI inferencing. Let's do a deep dive here, how we can integrate Kleidi into your tech stack. Whatever the machine learning or AI application you're using, starting from image classification to LLM and recommendation models, which are running with PyTorch, either what are the framework you use for your application, let it be like 1DNN, ASL, OpenBlast, etc. You can still plug in the KleidiAI, which is getting upstreamed in PyTorch. So whenever you download PyTorch, you get the optimizations of KleidiAI into your tech stack, and that really uses the ARM in-core accelerators, which are on CPU, and this brings up the performance gains for GenAI framework. So let us quickly jump into the demo and do some real-time testing of our demo. So here we have like two windows of the demo running the same demo. One is running the Llama 3.1 with Kleidi optimizations for PyTorch on ARM. The other one is without Kleidi optimization for PyTorch on ARM. Here we are running like 8 billion quantized in-4 quantized model running on R8G, AWS Graviton for instances, which are like 4x large. It's a 16-core CPU. So I'm gonna just jump in and ask a question here and other question there for this chatbot and just see like how the performance are. So I just typed what is AI inference here. I'm just gonna copy the same and just put it here on this. So I'm just gonna send this to both the chatbots here. So you can observe the relative difference in the performance. So this chatbot started bringing up the content for you, talking about what is AI inference. So here it still just waits for the content. So if you see it here, it started and bring up a lot of context for you. Here it took a long time. I can identify the delay in the response. It started bringing up the tokens, but it's still slow. Here when the when the content is shown up as a response, we got some of the metrics measured for you, like the time to generate first token. It's like 0.83 seconds, which is less than a second. And the decode token generation per second, which is like 32 tokens per second, which is quite satisfactory, and a massive performance upliftment. Here to continuing this speed, this fashion, it takes about like $8 to generate million tokens on this CPU on AWS, and it took like about 28 seconds to generate all this prompt. Here, it is taking a while to generate this. Meanwhile, we can just jump to the presentation and come back and read the output on this slow chatbot. So here, these are the results which we have seen on the real-time demo, but want to walk through to the dedicated results. So this is the token generation rate. You see like with the default configuration, it's about like 2 to 3 tokens per second. And when you integrate like KleidiAI into your tech stack for GenAI, you can see a massive performance upliftment between 35 to 40 tokens per second, which is quite impressive. At the same time, for the time to generate first token phase, here it's about up to 10 seconds by default to about like less than a second to about like 0.5 seconds. So with KleidiAI integrations. So the conclusion. So here we are quantizing the model using the int4 quantization, which brings up the accuracy scores marginally lower than the model's original accuracy. And we are using KleidiAI, which brings in like the massive performance gains and ecosystem strength. And this shows like we're doing like energy efficient AI on ARM. So this shows that AI inference on ARM CPU supports a wide variety of frameworks and delivers cost efficient and energy efficient and secure real-time performance. So let us jump to the demo and watch what's the output of our bot is. So here it's still getting the stuff for you. It is taking longer than expected, but here it just got your stuff. So this is how it's going on. So these are some of the developer resources. So to know more about this demo, you can just scan this and read more about this demo. And to replicate this demo and do it on your ARM-based server, try scan this QR and follow the learning path and just replicate this on your environment. And if you want to experience a similar chatbot on learn.arm.com, you can just scan this QR and do some chatbot tests and do some exercise with the chatbot on our learn.arm.com. And if you want to join the developer arm.com developer program, you can just scan this QR and join the community to build the future on ARM.
All right, now let's go to Gabriel Peterson, one of our own developer evangelists, who was there representing ARM at the event. Gabe, how's it going?
It's going great. Thanks, Mike. The PyTorch conference was a fantastic experience. ARM had a strong presence, showing AI running efficiently on ARM CPUs from the cloud to the edge using PyTorch and ExecuTorch. At the heart of this is KleidiAI, our open source AI library built by ARM to accelerate AI workloads on ARM Cortex and Neoverse CPUs. KleidiAI has already been upstreamed into ExecuTorch, and the integration with PyTorch is just around the corner. We had a steady flow of people at our booth, and it was great to show these optimizations in action. What really helped us stand out was the fact that people could interact with our demos firsthand, something I didn't see much of when I briefly walked around to look at the other booths. With Nobel's demo in particular, attendees even had the chance to take a link and try recreating the experience themselves. Being my first time at PyTorch Conference, I wasn't sure what the demographics would be, but I was glad to see there was a heavy turnout from engineers and developers. Not only that, it was really encouraging to see the level of engagement of those who came by, asking insightful questions and showing genuine interest in our technology. ARM also delivered 2 talks at the conference. You just saw an abridged version of Gian Marco's presentation, and Pareena Verma gave a lightning talk titled Empowering Developers, Tools and Resources for Running Generative AI on ARM CPUs. Links to the full talks are in the description below. Definitely check those out.
All right, now we're going to go to Pareena from our solutions engineering team to get some updates on learning paths that have come out in September, including a couple of highlights. Pareena, over to you.
Thanks, Michael. So we've had a busy month in September where we published quite a few new learning paths, especially for developers in the server and cloud space. So particularly around Gen AI, which is a hot topic, we released a new learning path, which is around deploying the Llama 3.28 billion parameter model using PyTorch with KleidiAI kernels and seeing the excellent tokens per second performance with these kernels added into PyTorch. We also updated our Llama CPP-based learning path where you deploy the same Llama to the Llama 3 8 billion parameter model, but this time using the Llama CPP framework with a live demonstrator running in the learning path. So you can actually touch and feel and use the live chatbot when you go to the learning path. This is all running on a backend AWS Graviton 4 instance. So that was an exciting update. But outside of the Gen AI space, we did a new learning path for developers who want to estimate performance issues with their ARM programs using LLVM's machine code analyzer. So there's this tool called MCA, and you can really use it to estimate your hardware resource, pressure on the hardware resources and the number of cycles that it takes to run your ARM program using this tool. So it's a nifty one to diagnose performance issues using the MCA and Compiler Explorer. We published a new learning path around codecs and deploying them on ARM servers, so particularly one for VP9 and the AV1 codec. And this one walks you through all of the steps to build the codecs on the ARM servers, deploy it, and run them using some example videos with various different resolutions and encoding schemas. In the CI/CD space, there was a really good one that was by Runzon. So there's a learning path that came in from our community. And this learning path demonstrates using ARM runners offered by AWS and using those self-hosted ARM runners in your GitHub Actions workflow. So you would install Runzon, which is a self-hosted runner utility or a manager for your AWS machines, and then you could execute those AWS Graviton instances as self-hosted runners using this Runzon utility. So definitely go check that one out. That was very exciting. So in the mobile space, there was a learning path that we published, which is for Vulkan developers. And if you're familiar with rendering and if you're interested in deploying ray tracing on your applications, that's a good one to go check out. It describes how the Vulkan ray tracing API works, how you can use it to implement like realistic shadows, reflections, and refractions, and basically implement the ray tracing effects using the Vulkan renderer. We all in the embedded and microcontroller space, we published a learning path also for Gen AI, and that's an interesting one because it shows you deploying the same Llama 8 billion parameter model, but this time on a Raspberry Pi 5 edge device. We're going to be updating that learning path pretty soon in the coming month because we're also integrating Kleidi, the microkernels, into the ExecuTorch framework. And so you can try it out today with ExecuTorch as it is and deploying the model on your Raspberry Pi 5. But in the coming weeks in October, we'll be updating those learning paths to show you how you can get even better performance once Kleidi is integrated in there. So lots of exciting stuff that happened in September. Please go check out those learning paths. And there's plenty more that I haven't even touched upon today. So go explore the different categories. And we'll be back in October with a new update of the learning paths that are to come. Thank you.
Thanks, Pareena, for that update. You can find those learning paths and many, many more at learn.arm.com. And if you're writing your own project that's running on ARM servers or devices, you can contribute your own learning path at that same site. Go check it out. And thanks again, Pareena.
Thanks, Michael.
That's it for this episode of Innovation Coffee. I hope you've enjoyed this update from PyTorch Conf. And be sure to come back and watch our future episodes. You can find out more about this and all the other things that we're doing in the ARM developer community by joining the ARM developer program at the link below. See you next time.